12 hours no class today?
Yes, sir. Yes, sir.
Okay, solve this problem. To 2020. I started at 7 o'clock. Up to 9 o'clock, no? Okay. Chalo, fatapat karenge. The thin lines of line suspended and rotated through n rotations. The rotational kinetic energy. So there is a thin rod. So there is a thin rod. Okay. So they are telling it is rotated. Make n rotation. So how will you consider the rotation? Will you consider, will you consider this rod to be rotating like this, or will you consider this rod, okay, will you consider this rod, right, to be rotating about this axis? Which one will you consider according to this? Which one will you consider?
Suspended from one end.
Suspended from one end. I can suspend it like this also here. This one I can suspend it from a string. This also I can do. So will you go for this or this? Or A or B? Which one will you consider?
So for B, say moment of inertia is 0. So angular moment is 0.
Huh? What did he say?
So moment of inertia in case of B is 0. So
How moment of inertia?
along that axis.
If you take one rod like this and if it is rotating, then the moment of inertia is 0. Arun, this rod will be like what? It's like a cylinder. Hello? This rod is like a cylinder. When it is rotating about the axis, then the moment of inertia of the cylinder is what? mr square. What is r? R is the radius of it. Got it? Hello? So if they what have they given? It is thin rod. See, that boy is correct. So since they have told thin rod, that means now this radius is negligible. Okay, its radius becomes negligible. Okay, then, and if at all you want to still calculate rotational kinetic energy, then R must be known. So therefore, this is not the consideration. Okay, then only this is the consideration. So this is very simple, rotational kinetic energy. So half I omega square. You have to find I at this point of the rod. So it will be ml square by 3.
Yes.
Okay, I. Okay, half I into omega square. What is omega here? Omega will be 2 pi theta square. Okay, so this will be the kinetic energy. Okay, so you just have to do this. So if you see here, so it will be m L square. Okay, and n rotations per second. It will be m L square pi square n square, and this will be 2 pi n square, it will be 4, isn't it? This 2 will cancel, only 1 2 will remain there, so you will be left with what? 2 by 3 m L square pi square n square, correct?
Yes, sir.
So C is the option.
Yes.
Correct? 45, C is the option. Right. So that rigid body, you can just take a rod if you want. About the center, and they are told now consider the axis at a distance d from the center. Okay, so this is the IC, and if you take this point as P, this is the IP. a rigid body of mass m, and they are giving you omega. Okay, about an axis at a distance d from the center. That means it is rotating about this axis with omega. Is it correct, students? What I have assumed?
Yes. Yes, sir.
So about this it is rotating with omega. Okay, the radius of gyration about a parallel axis through G, the radius of gyration about a parallel axis through G. That means now he is taking this axis. Correct? There is the radius of gyration he is taking it as k. So what is the kinetic energy of rotation of the body? See, you understood the problem?
Sir.
Actually, the body is rotating about this axis with omega. Okay, so therefore the kinetic energy will be what? Higher into IP into omega. Got it?
Yes. Yes, sir.
This is the kinetic energy of the system that we have stored. Now he is telling the radius of gyration about this axis is k. The radius of gyration about this axis is k. So the kinetic energy is what he wants. So this is quite simple. So half, what is IP? Parallel axis, IP is equal to IC into MD square into omega square. Clear? Hello?
Yes, yes.
Half. And this is equal to half. And now they are told radius of gyration is k. So IC I can write it as MK square plus MD square.
Sir,
Into
they are given, sir, the radius of gyration, sir, about the parallel axis to the G level.
See, now that's what I am telling you. See, first part of the problem you read. The first part of the problem you read. So what does it mean? That there is an axis which is at a distance d and about which it is rotating and about which it is rotating and we are rotating with omega. That's what they have told. Correct now?
Yes, yes.
Now the second part of the problem. The radius of gyration about a parallel axis, parallel to this axis. The axis through the center. See, you have to read it very carefully. Correct?
Yes, sir, yes, correct.
Then IC is written as this. So you get here half, m is common. You get here k square plus d square omega square. Do you have this option? Yes, option C.
Yes, sir. Yes.
Option C. That's it. So there is, see, the same concept, is tested. And I am telling you again, just NCERT book. It is just the NCERT book. Okay, so therefore you see the real teaching in the classroom should be with NCERT textbook. Word by word, bit by bit, aram se explanation. Every student can understand. Every student can understand. And that is how science has to develop. Yes, there are some very brilliant students, intelligent students. For them, even through the numerical problems, they will understand science. But they are gifted. Say 1 in 1,000. But I and most of you are not in that category. But that doesn't mean we cannot solve these problems. Understand? So therefore, the rule is this. In the classroom, NCERT textbook, learn through that. Solve the questions there. Okay, module is an exercise, additional exercise which the students have to do in their home. The teacher is not supposed to bring the module to the classroom and start teaching from the module. That's a guide. And because of that, today your fate is like this. You have hardly understood anything of these things, even though you have solved very difficult sums. But if the process was like this, every one of us would have understood. Okay, so please understand this. And since IIT, IIT seats are only very few, 10,000, 12,000 seats. So, in the 10,000, 12,000, out of 12 lakh students, 12,000 students are, okay, by the grace of Almighty, there are some gifted students. They are benefited by that module teaching. Not everybody. But there is a chance for everybody to excel, provided you learn like this. And there is enough time to learn like this. You see, each problem is from NCERT. You just watch out. So at least from now, you listen to me. Go dig into NCERT book and learn from that. Don't touch modules unless you are perfect. And go for the module questions in these. A weightless load is acted upon when upward parallel forces 2n and 4n, the total and the weight. Okay. So you have a rod, and this is NA and this is NB, and this is 3 meters. This L is equal to 3 meters. So there are two upward parallel forces, 2n at A. So at A, you have got a force here. At A, you have got a force here. At A, you have got a force here acting on this. And at B, you have got a force acting. And A is 2 Newton and B is 4 Newton. Right? So naturally, these two forces are not balancing it. Okay. So therefore, in order to balance it, you have to apply, and if it has to be in equilibrium, so there has to be a force downwards which will be equal to 6 newtons. Hello?
Yes, yes.
This has to be 6 newtons, right? And therefore 6 Newton force, where will you place? Definitely not at the center. You will say you will place it more towards the 4 Newton force. Okay.
Yes.
So now they are giving the option downward from A to B, downward at any point no, downwards at midpoint no. So option A, B is gone. Downwards at point C 1 meter. Where will this meter be? So this is 2 and n, and the length is 3. So therefore 2 into 2 is 4. 4 into 1 is 4 into 1 is 1. So 2 into 2 is 4 at this point. 4 into 1 is this. So this is 1 meter and 2 meter. So downward at a point C, such that AC is 1. No. Downwards at a point G such BD is 1. So option will be D.
Yes, please.
Okay, done. This was just a small problem. Experiment unknown mass 16 kg L1 M L2 M L1 L L2. So this will be very simple. So this will be what? 16 into L1 is equal to M into L2. First case. Second case, M into L1 is equal to 4 into L2. Okay, and they are asking you unknown mass here. So the easiest thing is there are only 2 equations, and well, there are 3 unknowns. Don't try to solve. See a simple way by which, yes, you simply divide one by the other. The L1s will go. Okay, so you get 16 by M is equal to M by 4. So therefore, M square is equal to 4 into 16, or M is equal to 2 into 4 equal to 8. So 8 kg. Yes, this is the option.
Yes, sir.
Okay. A rod is hinged at the center and rotated by applying constant torque from rest. The power delivered by the external torque is the force. So you have a rod, okay? You have a rod which is hinged at the center, okay, by a constant torque, and it is starting from rest. The power delivered by external is a function of this. So you are applying torque. What is the power? Power is, see, for linear case it is F into V. Here it is tau into omega. Okay, hello? It is tau into omega. and you are applying torque, and omega is something you have to, because they are asking you, they are told torque is constant. So here omega will be what? Because it is starting from rest, omega will be alpha into T. And what is alpha? Alpha is tau by I into T. Okay, and this becomes tau square by I into T. And they are told constant torque. So this is constant, and moment of inertia is also constant. So therefore, power is proportional to T. So B is the option.
Yes.
Okay, done.